Hi guys, I just wanted to quickly go over what today's focus was to be, and it is about exponential functions. That's what we're looking at. Okay. And so here's what exponents are, in case you didn't know. We have a base right here, this number right here, and that's the number that I'm going to be multiplying together. And we've got the exponent that tells me how many times I'm going to multiply that base together. The exponents are just a simpler way to write a specific type of multiplication problem. So when I have something like this, 3 to the fourth, that means 3 times 3 times 3 times 3, which gives me 81. The 3 is the base. That's the number that I'm multiplying. The 4 is the exponent. That tells me that I'm going to take 4 3's and multiply them together. Okay, so here are some more examples. If I have 2 to the third, what does that mean? 2 times 2 times 2. And again, we just do the math and get the answer. If I have 5 to the fourth, what does that mean? 5 times 5 times 5 times 5. Again, 5 is the base, 4 is the exponent, so I'm going to multiply 4 5's together. And 0.75 to the third, same deal. There's my base, 0.75. My exponent says take 3 of those and multiply them together. There it is. Okay? Now the question is, what key does your calculator have? The truth is, all three of these do exactly the same thing. They do exactly the same thing. So if I have 2 to the third, and this is the key I have on my calculator, I'm going to type in 2, x to the y, 3 equals, boom, I'm going to get my answer. If I have that same 2 to the third, and this is my key, I'm going to type in 2, y to the x, 3 equals, ding, got my answer. And again, same deal. If this is your key, I'm going to type in 2, caret, 3 equals, and then there's my answer. So you'll notice that how I'm going to type that in is exactly the same no matter which key I've got. But it's just that recognition that these keys tell you that you're going to type in base, then the key, then the exponent, and then your equal sign, and then you've got your answer. Okay, so that's how you're going to use your calculator to do this. And so now we want to look at an exponential function. What does it look like? Well, it's y equals a times b to the x. A and b are going to be numbers. Whatever number a is, that tells me that my y-intercept is going to be 0a. So whatever that number is going to be the y-coordinate of the y-intercept. Again, you're going to see that in just a sec. Whatever number b is going to tell me if it's growth or decay. And again, you're going to see an example of each one of those momentarily. And then obviously the value for x right here is going to change based upon what your equation is and what your values are. So here's an example of an equation. Now as I look at it, it's going up to the right, so clearly that's going to be what kind of an equation? Let's see. So here's the equation, y equals 2 times 1.5 to the x. That's going to be a growth equation. I can see that on the graph, right? It's going up as I go to the right. Why is it a growth equation? Because that value right there for b, the 1.5, which is in the b position, is bigger than 1. Okay? Anytime that number is bigger than 1, then that means we have a growth equation and it's going to look like this. It's going to curve up. Here's another one. Here's the equation for that one. Now compare those two equations. What do you notice? Well, clearly, when I look at the graph, I notice that this one is going to be a decay. How come? Because it is going down as we go to the right. And now it says, I know it's going to be decay if b is between 0 and 1. And look at my value for b. It's 0.5. It's a half. It's between 0 and 1. Okay? So that's how you're going to determine whether it's growth or decay. You're going to look at that b value. If it's bigger than 1, it's growth. If it's between 0 and 1, it's going to be decay. You will not have negative numbers in that position. All right? And now the y-intercept. Look at these two graphs. Each one of those two graphs crosses at that point 0, 2. There it is when I draw the graphs. Well, how did I know just by looking at the equation that that was going to be the y-intercept? Bam, the number in the A position. There it is. I've got the 2 in that A position. So that's going to be my y-intercept. So I know that's where it's going to hit the y-axis. And so that's what there's an example of what each one of those will look like. So now let's take a look at this table and make some decisions. I have this first equation, y equals 3 times 2 to the x. Well, it's either growth or decay. Well, why is it growth? Because that b value is bigger than 1. It's 2. And so now let's determine our y-intercept. What number is in the A position? Oh, it's 3, so that means my y-intercept is 0, 3. Let's look at the next one. We have 100 times 1.2 to the x. Again, that one is growth. How come? Because that b value right there is greater than 1. And again, my a value is 100, so therefore my y-intercept is 0, 100. Now let's look at this third one. Y equals 0.5 to the x. Well, that one's decay this time. Reason? My b value, which is 0.5, is less than 1 and greater than 0, so it's between those two. But I don't have a number right here. There's no number right here like there was here. There was 100 here. There was 3. If there's no number right here, it's a 1. So there's my y-intercept. Okay? And then the last one, got one more to do. Y equals 0.75 times 1.1 to the x. Again, we've got growth because the b value is greater than 1. A is 0.75, so boom, there is my y-intercept. It's that simple in regard to looking at that equation and determining those values. And so now let's talk about getting some answers to a table. Here's the equation that we're going to use right up here. And now let's fill in these values. So all I'm going to do is take that equation and plug it in. I'm going to put in 0 for x. Okay? 2 times 0.5 to the 0. Well, here a definition is that I get 1 anytime I have any number to the 0 power. So I have now 2 times 1 is 2. And guess what? 2 goes right into that spot in the table. And then let's keep going. We're just going to use that same equation. Now we're putting in 1. 0.5 to the 1 is 0.5. 2 times 0.5 is 1. And lo and behold, 1 goes in the table. Going to do the same thing again for 2. I'm putting 2 in for x. 0.5 squared is equal to 0.25. Well, 2 times that is 0.5. And guess what? Bam, that number's going right in there. And again, finish off those last two. I'm putting in the 3 for x. 0.5 to the third is 0.125 times 2 is 0.25, and in it goes. And last but not least, I'm putting in the 4. 0.5 to the fourth is 0.0625. I'd multiply that by 2, I get 0.125. Bam, I've just filled in that table. That's all there is to doing that. That is it. You just need to make sure that you're doing the exponent part first. Again, that's order of operations. And then multiplying each one of those by 2 here. Okay? And so let's get to those couple of definitions just so you're 100% certain. And again, it says b to the 0 is equal to 1. So if I have 100 to the 0, I just get 1. If I have 0.75 to the 0, I just get 1. I don't care what this number is. I don't care what it is. If it's to the 0 power, I get 1 for an answer. And then here's one. If the exponent turns out to be a negative number, this definition says just flip over the base. Get the reciprocal of the base. So if I've got b to the negative e, that's the same thing as 1 over b, which is the reciprocal, to the positive exponent. So what does that look like? So if I have 10 to the negative 2, That's the same thing as 1 over 10 to the second power. Notice that I just took the reciprocal of 10, which is 1 over 10, changed -2 to +2. And I have another one, 2/3 to the -5. Well, the reciprocal of 2/3 is 3 over 2. Just flip it over, and I changed -5 to +5. Okay? Hopefully that helps you. Again, I sent you those slides, so you have the slides, and then here's a little bit more description for you. Do your great job on those assignments.